Hello folks and welcome back. Today we're going to be jumping into a new chapter here, Chapter 8, starting with Section 8.1. This is inverse variation. Now to start off, we have two different tables. Both of them are linear functions. We're trying to determine what's different between them. Okay, well let's take a look at this first table here. For table 1, we have x is equal to 1, y is 19, x is 2, y is 38, x is 3, y is 57. So it looks like if we multiply each of these terms by 19, that's how we get this, right? 1 times 19 is 19, 2 times 19 is 38, 3 times 19 is 57. So we have no y-intercept here. Our y-intercept is 0, and this is what we called direct variation. Right? To get from x to y, all we had to do was multiply by a number. And what did we have to multiply by? We multiplied by 19. So this is y is equal to 19x, or y is equal to 19x plus 0. What about for the second one? Well, we have 5, 13, we have 6, 15, and we have 7, 17. So it looks like we're increasing by 2 here. Right? So we're going up by 2, so we have 2x, but we don't have, or we have a y-intercept here. Right? If we went all the way back to 0, we would not end up at 0, so we can't figure this out immediately. So today we're going to be looking at direct variation as well as something we call inverse variation. Direct variation took the form y is equal to kx. Or in other words, this is just a linear equation with no y-intercept. What is k? K is what we call our constant of variation, or it's how fast we change y in relation to x. So k is the constant of variation. Okay. How do we know if something is direct variation? Well, when we're looking at our x and y values, we expect the ratio to be the same. So the ratio between x and y is always the same. Or in other words, each time we take y and divide it by x, it should stay the same. The other side of this is what we call inverse variation. And so instead of these increasing proportionally, they vary inversely. So this is y is equal to k divided by x. So now we're dividing instead of multiplying. Again, k is going to be our constant of variation. And why is this inverse variation? Well, because as y increases, x decreases proportionally. So as one variable increases, the other decreases. So they work inversely of each other. How do we determine if something is an inverse variation? Well, if we multiply y and x together, right, we can rewrite y is equal to kx as y times x is equal to k. So the product of y times x should always be the same. So direct variation is y is equal to k times x, right? Whereas one increases, the other increases. And then we have inverse variation, y is equal to k divided by x, whereas one increases, the other decreases. Now we're going to take a look at a couple of examples, actually just this first example, Determine whether it's direct variation, inverse variation, or neither. Then we're going to write the equation of the graph. So to start off, we have 215, 4, 7.5, 10 times 3, and 15 times 2. What happens if we take y and divide it by x? That's how we determined if it was direct variation. So let's try that out. 15 divided by 2, it's going to give us 15 over 2, which, put that into your calculator, that should be 7.5. Okay, then the next one is going to be 7.5 divided by 4. Let's throw that into our calculators. 7.5 divided by 4 is not going to be the same. It's going to be 1.075. So we know this isn't direct variation. Right? We're not keeping the same value when we divide y by x. Okay? Now let's try multiplying y times x, see if it comes out to be the same thing. So y times x, 2 times 15 is going to give us 30. 4 times 7.5, that's going to give us 30. 10 times 3, that's going to give us 30. And 15 times 2, that's going to give us 30. So this is inverse variation here. When we multiplied y and x together, it came out to the same value. And what was that? It was y times x is equal to 30. So when we write this, we want to have x on the denominator. We want y by itself. Our equation is y is equal to 30 over x. So this is our equation. Y is equal to 30 over x. Or in other words, the value that you get when multiplying is the value that is your constant of variation. So that's our equation. Let's graph this. We have some values here. We know we have 215, we have 4, 7.5, we have 10, 3, and we have 15, 2. So let's graph this. We're going to go up by 5s. And 15. Okay, so we start off at 2, 15, and we go to 4 and 7.5, and we go to 10, 3, and 15, 2. And now as we connect these, we notice that it looks like a curve, a little bit like a reverse bow here. We'll deal with that more in our next lesson, but that's the way these graphs look. Right. Now it's your all's turn to figure out whether these are direct variation, inverse variation, or neither, and then write the equation. So starting off with this first one, 0.2 and 8, 0.5 and 20, 0.1 and 40, and 0.5 and 60. Is this direct variation, inverse variation, or neither? And what's the equation? Let's start by trying to divide, see what that gets us. So we take y over x. That's going to be 8 over 0.2. Put that into your calculator. 8 divided by 0.2, that gives you 40. So 40 is what we're looking for. What about 20 divided by 0.5? That's also 40, so we're off to a good start. 40 divided by 1 is 40, and 60 divided by 1.5 is 40. So we are dividing these two. It's a ratio, meaning that this is going to be direct variation. How do we find out the equation? Well, we know y divided by x is equal to 40. So now let's separate y to get it by itself. To do that, we multiply by x on both sides. We get y is equal to 40x. Okay, so this is direct variation, and our equation is y is equal to 40x. What about this second one? Is it direct variation, inverse variation, or neither? And what's the equation? Right, let's start out by trying to divide. We're going to take y divided by x. So that's going to be 40 over 0.2. 40 divided by 0.2 gives us 200. Okay, what about 16 divided by 0.5? That gives us 32. So we know this isn't direct variation. These two are different. Right? Dividing tells us whether it's direct variation. Multiplying tells us whether it's going to be inverse variation. So now we're going to multiply x and y together to see what that gets us. So y times x, 0.2 times 40, is going to give us 8. Okay, 0.5 times 16, that's going to give us 8 as well. 1 times 8 is 8, and 2 times 4 is 8. So y times x worked. If we go back up to our set here, If we multiply them, that means it's inverse variation. So this is going to be inverse variation. And what did we find was true? We found that y times x always equals 8. Y times x always equals 8. So now if we're trying to isolate y, we're going to divide by x, and this will give us the equation y is equal to 8 over x. Okay, one last one. Is this direct variation, inverse variation, or neither? And what's the equation? All right, let's start by looking at y divided by x. 40 divided by 0.5 is going to give us 40. Divided by 0.5, that gives us 80. 16 over 1.2 is going to give us 13.3. Repeating. So we know it's not y divided by x. Let's try y times x. What's 0.5 times 40? That's going to give us 20. What about 1.2 times 16? That gives us 19.2. So dividing nor multiplying worked. That means that this is neither. Let's do one more example here. This time we're saying x and y vary inversely, and when x is equal to 4, y is equal to 12. So we know that when x is equal to 4, y is equal to 12. That tells us that 12 is going to be equal to k over 4. Okay. So what function models this? Well, we know 12 is equal to k over 4 because it's varying inversely. That's y is equal to k over x. So what's k going to be? It's going to be 12 times 4, or 48. So we know that k is 48. Our function will be y is equal to 48 over x. And now the question is, what does our graph look like? Okay, well, let's start out by trying to make a table of values. We're going to have x and y here. To make this table of values, it also might help to think about this as y times x is equal to 48. So in other words, we're looking for two numbers that when multiplied together make 48. What do we know that's going to be? Well, if x is 48, y has to be 1. And if y is 48, x has to be 1. Okay, 48 is divisible by 4. So let's see what that gets us. 4 times 12 gives us 48. So if x is 4, y has to be 12. If x is 12, y has to be 4. Okay, what about the negative values? Negative 4 times negative 12 also gives us 48. So we can also say this is negative 12 times negative 4 and negative 4 times negative 12. Okay, so we have negative values and we have positive values. Let's try to graph this now. We go like this. Let's go up by 5s, 10, 15. I'm going to go into our negative values as well. Okay, looks like we might need one more set here. So what's 48 divided by 6? 48 divided by 6 is going to give us 6 and 8, as well as 8 and 6, and their negative values. So 48 and 1 and 148, those are going to be too far out, but let's start off with 4, 12, and 12, 4, as well as negative 12, negative 4. So we have negative 12, negative 4, and negative 4, negative 12. Then we also know we have the value 6, 8, and we have the value 8, 6, as well as the negative versions, right? Because negative 6 times negative 8 equals 48 as well. So we're going to go out to negative 6, negative 8, and negative 8, negative 6. So it looks like we have two separate curves here. If we draw them in, we have one curve that looks like this, and another curve that looks like this. So that's what our graph looks like. One last set, we're going to try some real-world problems. Our math class, we're deciding that we're going to be good citizens. We're going to pick up litter each weekend in the local park. Each weekend, there's still the same amount of litter because people come back and they keep throwing their trash everywhere. but we had a different number of students each time. Here's the number of students and the amount of time it took for us to pick up the litter. When we had 3 students, it took us 85 minutes. When we had 5 students, it took us 51 minutes. When we had 12 students, it took us 21 minutes. And at 17 students, it took us 15 minutes. So what's an equation that represents this? We're noticing that as our number of students increases, our time decreases. So as one increases, the other decreases. That seems to be inverse. Let's see what happens when we multiply x times y together. X times y together, that's 3 times 85. 3 times 85 is going to be 255. Yeah. What about 5 times 51? 5 times 51 also gives us 255. 12 times 21, that's also going to be 252. Okay, so it doesn't quite work. What about 17 and 15? 17 times 15 is 255. So what does this mean? It means our constant of variation is very close to 255. We just had that one outlier, which was pretty close. So our constant is very close to 255. Let's use 255 as our value. So our number of students times the time it takes will always be equal to 255. Or we expect the time it takes will be dependent on our number of students. So time would be equal to 255 over n. So that's our equation. And it's asking us how many students will it take to get the job done in 30 minutes. So for this, we're going to say, well, t is going to be 30. It's equal to 255 over n. What's our number of students? Our number of students times 30 will equal 255. Or n will be equal to 255 over 30, which is going to be, let's see, 255 divided by 30. That's 8.5. But we're going to need more than 8 students. So this will be 9 students we need. Okay, so we looked at the values. We saw that one was increasing, the other was decreasing, which led us to believe this was inverse variation. We found our constant, we set up our equation, and we could figure out how many students would it take to get it done in 30 minutes. Now let's have you all try one. This time it's you and your friends are starting painting. You're painting fences, and the amount of time it takes varies indirectly with the number of friends, or inversely, specifically. So here's a table of the number of friends versus the time. With 1 friend, it's 225 minutes. With 3 friends, it's 75 minutes. 5 friends, it's 45. And with 14 friends, it's 16 minutes. Tell me, what function models this situation? So if we know it's varying indirectly or inversely, let's check out what f times m is for each of these. 1 times 225, it's going to be 225. 3 times 75, that's also going to be 225. 5 times 45 is also going to be 225. And 14 times 16 is going to give us 224. So it's very close here to 225. What does that mean? It means that f times m is equal to 225, or m is equal to 225 divided by f. Or vice versa, we can say that the number of friends we have that we want is 225 divided by our number of minutes. Okay. What about the second part? If the goal is to finish each fence in 25 minutes, how many people do we want to have for the job? So if we want to finish the fence in 25 minutes, m is going to be equal to 25. So that means that 25 will be equal to 225 over f. Or solve for that, that's going to give us f is equal to 225 over 25, which tells us we want to have 9 friends on the job. And folks, that's all there is for this lesson. That's your start to inverse variation.